Hello guys, welcome to my YouTube channel. Today we are here to solve Leetcode problem of the day. Today is 21st Feb 2025 and the today's problem is find element in a contaminated binary tree. So from the title of the problem statement, what we can think that what could be the problem. So you have to find element in a contaminated binary tree. So this says that there will be a binary tree and you have to find some element. I don't know what will be the at this position. We don't know that what could be the element which we need to find out, but there will be the binary tree and we need to find the element. And there is the binary tree will be look like contaminated. Maybe we'll say that what is the contaminated binary tree. So this is the contaminated, so you can see here is something like -1 and it's converting to 0 and 2. Similarly this is the way and then it's converted to 0 1 2. So from this figure you can think that it is something like giving the number to each node in the binary tree. So 0 1 2 3 4, okay, and this 0 2 5 11 something like that, and then look at the constraints that each tree node have the value of -1 and the height of the vanity is less than or equal to 20. Maximum height will be equal to 20 and the total number of node in between 1 to 10 raised to the power 4, and total call can be made for the for the find what the hell we can confirm it. Okay, so you can see that this is the find class, sorry, this is the find method, and where you need to there will be a given target and you will have to find boolean value that either it isn't or not, something like that, and then total calls this and the target integer will be in between 10 to the power 6 to from 0 to 10 to the power 6. Okay, so this is something, this is the binary tree problem. So let's start with reading a problem statement, what is given in it. So you are given binary tree with the following rules, that root dot value equal 0. That means that the root of the element should be 0, and for any tree node, if tree node value has a x, then tree node dot left is not equal to null, and tree node dot left is not equal to null, then the left side will be equal to 2 into x plus 1. Similarly, if the has a value x, if the node has a value of x, and the right child will be the right child will not be the null, so the right child will be 2 into x plus 2. So this will be the structure of the binary tree, and now the binary tree is contaminated, which means that all tree node dot value have been changed to -1. It means that initially it was each node which is not null have the value corresponding to this rule, but after that it has been changed to -1 each value in the node. So implement there is a class given, so you can see here it is the class that name is find element, and what the find element is initialize the object with the contaminated binary tree and recover it. Okay, and the boolean find return true if the target value exists in the recovered binary tree. It means that at the beginning what you have given, that you have given a tree and each value in the tree will have the value of -1, but when we will recover it with this rule, that the root value have the value of 0 and the left child will have the value of 2x plus 1 and right child value will have the value of 2x plus 2. So we will convert this contaminated to the original binary tree, and then you will have to find that either a specific target value is present in the binary tree or not. So this is all about the problem. Let's see the example 1. Here -1 and -1, and we recovered 2, 0 and 2. Why is right child? Because the value to the root node is 0 and then left will be 2 into 0 plus 1. So if there will be the left child, it could have the value of 1, and because you have the right child, so the value of the right child is 2. So you can see that if there is the query of find element 1, so is it 1 is present? No, so that's why the answer is false. And again a new query for the value of 2, so you can see that 2 is available in the tree, so that's why the answer is true. So you just have to convert the given binary tree according to the rule that are given here, that the left child will have the value of 2x plus 1 and the right child will have the value of 2x plus 2. So similarly you can see in the second example that at the beginning each node have the value of -1 and we assign a value of 0 to the root node, and left child 0 into 2 plus 1 and 0 into 2 plus 2. So that's why 1 and 2, and again the right child 2 into 1 plus 1, that's why 3, and this node have the value of 4 because 2 into 1 plus 2, so that's why 4. So there will be the query, you can find that target is present or not. So here is the example. Is 1 is present? Yeah, 1 is present. Then 3 is also available there, and then 5. Is it 5 or available there? Yeah, no, 5 is not available there, so it will be the it will return false. Similar for this node, you can see it has 0 and the right child will be 2x plus 2, so that's why 0 plus 2 is 2, and then left child, then 2 into 2 4, then 1 5, the 5 into 10 plus 1 11. So you can see that this contaminated binary tree has been converted or recovered to this tree. So if there will be the query, you can either make a DFS or BFS to check whether in specific target value are present in the binary tree or not. So this is all about the problem. If now we will have to see that how we will make our approach so we can bring with the optimum solution. So let me show you that how we will approach. Wait a second. Okay, so this will be the tree. At the beginning we will just assign a value and then we will call for the left. If there will be the null, what we will do nothing, but we pass the value of parents. So at the beginning we will consider it as parents, and we will pass the value of 0. If there will be the node, we will assign a value with a given rule. So it has the 0 in the right, 2 into 0 plus 2 into 0 plus 2. So this will become 0 and plus 2. So that's why this has been converted to 2 again. So it has been converted to 2. then this is the left child, so 2 into this value is already 2 plus 22 plus left child is 1, so that's why it will become 5. So you can see that this has been converted to 5, and again it has been 5, so the left child will be 5 into 2 plus 1. For the left child it will be plus 1, for the right child it will be plus 2, because it is the left child, so we will not consider it, so it will be equal to 11. So you can see that this has been converted to 11. So this is the simple, DFS approach. You can also do the same with the BFS as well. So we will first consider to solve the problem with the BFS approach, and then if you will like to let me solve the problem in the BFS, we can also solve it in the BFS. So this is all about the approach, and of course this week is purely dedicated to the recursion plus weekly is purely dedicated with the recursion and backtracking. So if you backtracking, so if you like to practice the recursion and backtracking, you can solve all the problems that are given in the problem of the day in this week. You will have a better understanding of recursion and backtracking. So let's start to solve the problem now. So one more thing here, that what will be the expectation, what is the requirement of this problem. A requirement of this problem, that there will be a given value and you will have to check that it's whether this element is present or not. So you'll have to just check that either this current element is present in the tree or not. So what we will do, we either you can use the hash map, or you can use a simple array to store the presence of the each value, because each node have a unique value. So you can you can store you can check a boolean, you can take a boolean array where you can store your information, either is present or not. So that's like whenever it will be 0, so at the index of 0, 1, 2, 3, 4, and similarly if you will make it like 11, this is 11. So whenever we will start with 0, so we will mark it as true, then 2, so at the index of we will mark as true, and then again 5, the index of, let's suppose it is 5, then we will mark it as 2, and then 11 we will mark as 2. Remaining element in this array will be false. So whenever there will be the query which is not available in the tree, we can return it in order of one time. So this is the approach. So let's begin with the coding now. So what we will need, do I need an array to store, like boolean to store, let's suppose this name is scene equal to new boolean of size. What will be the size? So we can consider a maximum size that could be possible. So let's suppose it's 1 2 3 1 2 3 6 7 plus 1. Let's say this is the scene statement. So here what we can do, that we will return the scene of target. So this is the boolean, So this is now you will have to make it. So how we can do this? We have to have the value. So we will make another method public what it will return. It will return nothing at the beginning. We will see if there will be the requirement to return something. We will return it. So it's like say DFS tree node root, and then there will the value of parent. Okay, and they will call it oh, you'll have to make a tree node. Here what we will do, we will make a root node. This root equal to root. Okay, yes. If root will return, else we will mark a casino parents equal to true, and we will call this for the left child. So root dot left, then what will the value 2 into, you can see the rule is 2 into x plus 1, so the parents is parent plus 1. Similarly for the right subtree, 2 into, okay, I think that's okay now. Okay, so it has been completed. We'll mark it as true. Root this root, and do I need to modify the tree, or do I need to just store the availability of all node in a boolean array? So we do not need to modify the array, because we, what is the expectation, we just want to know that either this target value will present if we will recover the tree from the contaminated tree. So you just have to find that either the target value is present or not. So we will not modify the tree, we will just store the information that this node is will be present in the recovered tree. So I think it's done now. None. Do I need this? I think not. I don't need this. This one also I don't need this. So let's try to run it now. So the answer is giving the false. Here again false, and then again false. See, let's see what happens. It's getting changed or what? Parents root to the beginning to the sorry, we have not called it. This method we need to call it from here, so that I just made it. So we will call it from the constructor. So we will call it DFS, and we have given the root, so root will be present there, and then because we are not present. So as it is mentioned that the root element have the value of 0 here, so we will assign 0 to the root. So let's try to run it now. So you can see that all the three test cases that are available temporarily in the test cases have been passed. Let's try to submit it now. So you can see that our code have been submitted and have been accepted as well, and that beats 26.68% of the people who have submitted in Java. See the memory that we have occupied 58.31 MB, that beats 5.93% of the people. So this is the very basic problem of recursion actually, that how we made the recursion in binary tree. So you can see that we have not modified the tree, see what is we have just seen that what is our requirement, and accordingly we solve the problem. So this is all about the problem. So if you have any query, or you feel bad, you have any better idea that how we can solve it, you can comment below in the comment box. We can also convert this in, it is the recursion, but we can do the same BFS and using the while loop instead of making the recursive call. So thank you. Please, if you it is helpful for you for the coding and DS and CP, you can follow my channel. Please share and subscribe to your friends who are interested in coding. Thank you.